Many methods don't have details given. For some reason, many of these researchers are very stingy in their description of the stages. Demirjian has been very liberal, so he's given very nice description as to when do you say it's 9, when do you say it's 8. So that's made our job a little easier. So I've staged this. Next, based on the stage, Demirjian says give an appropriate number. So for 3-1, if you have said stage 9, give it the number 10.61. 3-2 also, stage 9, number becomes 10.89. So like that, for the stages that I have given for these 8 teeth, you will notice that I have highlighted the corresponding number here. So we call these numbers as scores, maturity scores. So next, Demirjian says add up these numbers. Add these numbers, and so when I have added those numbers here, I've got a total as 89.56. Now Demirjian says substitute this number in a formula. So S is this total, it's called as total of the score. So substitute this S value in a formula. Now remember, forensic, the way I work on forensic, it's full of formulas, lots of formulas. And I'll be showing you plenty of formulas. And the important thing is not to get intimidated by these numbers. Remember, they're just numbers. You know, we are very capable of handling numbers. And with software such as Excel or even a simple calculator, you can use these numbers in a very easy and efficient manner. But I'm warning you, there will be plenty of formulas and numbers that you'll come across. So this was the formula that he has given. And he has given separate formulas for males and females. That's because the way males and females develop is different. Females are always faster than males when it comes to their dental development of virtually all the teeth except the third molar. So when it comes to the third molar, males slowly end up overtaking females. So finally, males actually end up having their dental development completed first. It's a classic hare and tortoise story. Females are way ahead, but then the males slowly end up overtaking them. In any case, hence we have these separate formulas. So the previous radiograph actually belonged to a female. So I'm going to substitute that total right here, 89.56. I'm substituting it here. And you'll notice I've estimated the age as 12.5 years. Now what was the actual age of this subject? This was from a research that we did. So I knew the actual age. So the actual age here was much more. It was 15 years. So this degree of difference, 2.5 years, is actually a little high. So for a child of 15 years, if you get a 2.5 year error rate, so this difference you see, 2.5 years, we call it as the error rate. So that error rate of 2.5 is slightly on the higher side. So why could we have this relatively high error rate? One possibility is that Demirjian has given a formula based on European children. So we are using a European formula on Indian children. And that may not completely work. So it's essential that we have a formula that is custom made for Indians. And that's what many people do, develop a customized formula for their own population. And that's exactly what we did too. So we've developed these Indian formulas, and now when you substitute 89.56, you notice that there is a marked improvement in estimating the age of the same case. So using population specific formulas, that's what this is called as. So such population specific formulas are vital in age estimation. It can enhance your estimation of age. So this is as far as Demirjian's method is concerned, at least for the time being. I'll come back to Demirjian's method a little later. But next, let me talk about another more recent type of method. This is called as the open apex method. This was developed by some Italian researchers. And what these Italian researchers have said is that, look at the lower left side teeth. They've deliberately used the lower left side teeth because Demirjian also had used the lower left side teeth. So if someone wants to compare which of the two methods is better, that way we are able to easily compare it. So it is deliberate. So they've looked at the lower left side teeth, and they've only looked at up to the second molar. I think there is a recent article wherein they've tried to use the third molar, but because the third molar roots may be highly curved, it's not very easy to perform this method on those teeth. So perhaps its application would be more on 3.1 till 3.7. So what these researchers have said is, on a radiograph, measure the width of the so-called open apexes. Now, don't get confused by this word open apex, because what they are referring to is the apical portion of the tooth. So that apical portion may be well at the CEJ or may also be in the crown itself. So it's not the open apex of the root, it is merely the apical region of the tooth. Now, the people who developed this method are actually anthropologists, so they sometimes don't understand the technical terms which we as dentists use. That's why you'll see these variations in the terminology. So you have to try to understand what is it that they're really referring to. Now, in addition to the open apex, they've suggested to measure the height of the tooth. So measure the maximum height as a perpendicular to that width of the open apex, and then calculate the ratio, the width divided by the height for all the teeth. Whichever teeth are still developing, in this case 1, 2, 3, 4, 5, all these teeth you have to measure the ratio, and that has to be added. Now what if some of the teeth are fully developed? Sometimes the first molar may be completely developed. So if it's completely developed, you just count how many teeth are fully developed. That's called as N naught. Now finally, they've actually, along with an Indian researcher, have developed an Indian formula for age estimation. And what we finally need to do is add these ratios right here, put in the number of completely developed tooth at here, N naught. What is the C? C actually is a figure which is 0 if the child is from North India or Central India, and it is 1 if the child is from Southern India. So they found minor variations in the way the teeth develop in children from South India and from Central, West and Northern India. Hence, you have to make that slight change there. 0 for North India and 1 for Southern India. And based on this, we end up getting the age of the child. So this is another method that you can consider using, but remember, a limitation may be that you may end up using it only up to the second molar. Third molar length measurement particularly may be a little difficult. So now we've estimated the age using either Demirjian's method or open apex method. How is all of this useful in the Indian context? Now there are a variety of sections of the Indian Penal Code which defines what age is eligible for what or responsible for what. And if you look at IPC section 82, it says that any child who is less than 7 years of age is not criminally liable. What does criminal liability mean? Liable means you are not culpable. You cannot be considered as being responsible for something. So, lack of criminal liability means a child who is less than 7 years, even if that child murders someone, it is not a murder. It's not a murder. Why? Because the child is so young, he or she is not in a position to understand the gravity of his or her actions. So hence you cannot treat that as a crime, as a murder. So sometimes we may get a child for age estimation as whether that child is less than or more than 7 years of age. Now, under certain circumstances, that lack of criminal liability may extend up to 12 years. If the child is not sufficiently well developed mentally, it may be extended till up to 12 years. That's what IPC section 83 says. Now, I'm sure you have come across the fact that any child who is less than 14 years cannot be employed. That constitutes child labor. So this is another type of case that one may encounter. The police or the labor commissioner's office may bring you a boy or a girl who's been caught working in a hotel. So is this person less than or more than 14 years? If you say less than 14 years, the hotel owner may be charged with abetting child labor. 15 years is the age at when a child can perform slightly more harsher work, more rigorous work. So a child can be employed in a factory only after he or she is more than 15 years of age. So these are certain sections of the law in which age estimation in these cases can become important. Now, there's one other very important area, and I'm sure many of you were reminded of it just a couple of days ago, when Ajmal Kasab was caught after the events of 26 November 2008. Immediately he was given a defense lawyer. That's how it should be. That's how the legal system in India works and should work. So you have a prosecution lawyer who brings a case against the terrorist, and you have a defense lawyer who tries to defend him. So the defense counsel said that on the day of the terror attacks, Ajmal Kasab was less than 18 years old. And the reason why he said that Ajmal Kasab is less than 18 years old is because anyone who is less than 18 years is considered as a juvenile, and they are not eligible for the death sentence or life imprisonment. So at the most they may serve 3 years imprisonment, that too in a juvenile home. So consequently, the honorable judge in that case said, right, to confirm whether Ajmal Kasab is less than or more than 18 years, we need to give him a bone ossification test and also undertake a dental examination to determine his age. He was given a dental examination by certain dentists in Mumbai. And which tooth do you think they would have used to try to determine whether he is 18 years or not? So the third molar becomes extremely important in such cases, because all other teeth are fully developed. There is only this one tooth that we are left with. So we can use the third molar, and we can use the same Demirjian method to assess the third molar development. But then I believe we should use slightly different type of statistical analysis. Now, statistics is also a very important part of the work that I do. And again, I feel that many of us may have a kind of an inhibition to work with statistics, but when you start working with it, you'll perhaps realize that it's a wonderful tool, a very important tool in a lot of the work that we do. So try to understand the statistics, and we can actually use it to our advantage. So this analysis is not done very often, not just in India, perhaps around the world. Not many people actually use this kind of an analysis. And I talked about this even in sex assessment. It's the same analysis that I use even in sex assessment. So when you want to predict whether a person belongs to one of two groups, so the two groups may be either male or female, wherein you want to measure the teeth and determine whether a skull is male or female, or the two groups may be less than or more than 18 years old. So in this case, in this living subject, you have to look at the dental calcification of the third molar, and based on the developmental stage, if Demirjian's developmental stage is 3, we then are able to say that there's a 96% chance that that person is less than 18 years old. So this way, using the third molar and using some good statistical analysis, we can give a fairly objective answer. Now, you must also understand the limitations here. Third molar inherently is a very highly variable tooth in its development. It's unpredictable to an extent. So you can't use the results as an absolute perfect answer. So you must be very careful. You must use it very cautiously, but it definitely has a lot of importance, lot of use in many of the cases. So now, as I said, in Indians, the accuracy of using the third molars is just less than 80%. So you have to realize that 2 out of 10 cases you may get a wrong answer. So thereby the necessity to be a bit more careful. So how does application of 18 years bear out in the Indian legal scene? Now, I just mentioned a couple of these points. First and foremost, that the Juvenile Justice Act of 2000 says that any person who is less than 18 years is considered legally as a juvenile. That is, the person is not an adult. I also said that that's the minimum age to enter government service. It's also the legally accepted age for consent. That's what IPC section 87 says. Now there are a few other important sections you may need to remember. One is IPC section 375. I think you may now be aware of this courtesy of the Nirbhaya case, because it says that sexual intercourse with a female less than 18 years, even with her consent, amounts to technical rape. So previously it was 16 years. After 2013 January, it was amended to make it 18 years. Now, IPC section 366A says that kidnapping of a minor, a girl who's less than 18 years, can be construed as trying to get her into illicit sex trafficking, and that can amount to a 10-year imprisonment. Lastly, of course, as per the Child Marriage Prohibition Act, it's also the age at which a girl can legally enter into wedlock. Not to mention, that's the age when we all get our voting rights also. That's because we legally become an adult. We are no longer minors at this particular age. So this is as far as age estimation in children and adolescents are concerned. Let me now focus my attention on another important age group, that's age estimation in adults. Now there are a variety of methods that we can apply in this particular age group, and when I say adults, I'm talking about more than 20 to 25 years. So we can either make use of morphologic methods, histologic or radiographic methods. We can also make use of certain biochemical methods which are extremely accurate but not perhaps very feasible to undertake. We may not be able to undertake it in a dental college because the equipment we need, I don't think any dental college anywhere in the world is likely to have it. So if you have a well-developed university, then you may be able to undertake some of these methods. There are certain methods which require an instrument called as an accelerator mass spectrometer. That is unlikely to be available in most universities. You may get it in places like the Baba Atomic Research Center. You may get it in the Indian Institute of Science. So by and large, it may not be available. So although very accurate, some of these methods are not really practical. We may not be able to do it on a day-to-day basis. And it's for this reason that I'm going to focus on things which we can easily undertake in our colleges, in our oral pathology or oral medicine departments. Let me, however, begin with a morphohistological method. And I'm beginning with this because this is perhaps one of the oldest methods for age estimation in adults. It's named after the person who developed it. His name is Gustafson. He is from Sweden. So what Gustafson said is that we can assess age using certain changes that occur on the surface of the tooth and also on some of the tissues within the tooth. So that's why we call it as morphohistological method, because you can appreciate certain aspects on an unsectioned tooth, but certain other aspects you will have to section it and examine it on the inside. So which were the changes he has suggested? Attrition, secondary dentin deposition, dentinal translucency in the root, and he's also suggested the usage of cementum apposition, root resorption, and something called as periodontal ligament recession. Now, if anyone wants to have copies of these presentations, gladly I will share it with you. You can just send me an email later and I'll gladly share the presentation with you. So I do that with hundreds of people around India. So do let me know if you want a copy of this presentation. You're most welcome to use it for your personal education use. Now, what do we do with these 6 parameters, with these 6 variables? So Gustafson says that let's grade these into 4 stages: grade 0, grade 1, 2 and 3, a total of 4 grades or 4 stages. And to get a better idea about what these 4 stages refer to, he says that look, if attrition is non-existent, we give it as A0. Similarly, if there is no translucent dentin, then again it is E0. The moment attrition has started within the enamel, it is A1. Now you notice translucency is in the apical third, so that's T1. Attrition has reached dentin here, so it's A2. Translucency has gone into the middle 1/3, so it is P2. And here, of course, attrition has reached pulp. Translucency has reached the cervical 1/3. So basically, he's saying that as the amount of change is higher, the grade also correspondingly increases. Now, it's not necessary that a tooth should have all of these as 0, or it's not necessary they should all be 1. It can be a mixture of 0, 1, 2 and 3. For example, like this. So here, and this is from one of the earlier articles, and I'll be talking about this in the next slide. It's a diagram given in one of those articles which talked about Gustafson's method. So here, if A2, S2, that means secondary dentin is 2, and the rest are all 1, what Gustafson says is that add these numbers. So that's 2 plus 2 plus 1 plus 1 plus 1 plus 1. We get a total of 8. That total needs to be substituted in this formula, and we get an age of around 48 years. So this is what Gustafson suggested. Using a variety of morphological and histological parameters, using certain statistics, he said, estimate the age. But soon after, and this method was developed in 1950, so it was one of the very early methods. Soon after, people started realizing that it may not be very accurate, and there are certain faults in the statistics used. So one of Gustafson's colleagues, I think he was almost like a student of Gustafson, with Gustafson's permission and support, modified it. And instead of 4 grades, he has given 7 grades. So the person who's done this is named as is Johanson, Gunnar Johanson. He is also from Sweden. So Johanson actually modified the grading system by adding a decimal between each of the original 4 grades. In addition, he also revised the formula. He gave a much bigger formula. It's much bigger because you see he's giving each of those 6 variables, each of those 6 parameters, is giving them separate weights. So this is what is more appropriate. Statistically, this is appropriate and not what Gustafson had done. So today it's Johansson's modification that we should use, if at all, and not the original Gustafson's method. So what I'd like you to try to remember is at least that Johanson has proposed these 7 grades. In spite of this modification suggested by Johanson, there still are certain disadvantages. And one of the biggest disadvantages is that you need to have extracted teeth, which means if you have a living subject, you can't really estimate the age until and unless the tooth is indicated for extraction. Another disadvantage is that the variables can't be used alone. You need to have all 6 of them together. Only then can we use the method. Now, it's for this reason that certain dentists tried to look at a single variable. They encountered situations when many of those variables were not available. So they started looking at those variables which are very commonly seen, commonly encountered. And one of those variables which was very easy to undertake, easy to perform, was dentinal translucency. Now, I've already shown this photograph wherein I've compiled sections from 3 different individuals of different ages. And this is to show that the dentinal translucency length actually increases as the age of a person increases. So what we expect is that older the person, greater is the amount of translucency. Now this translucency, what you see here, is based on tooth sections. But we can actually just take an extracted tooth and measure the translucency length on these extracted teeth by using a caliper. Just hold the extracted tooth against some source of light. You'll be able to see a little bit of translucent zone. It may not be very easy though, because it looks a little diffuse, but you can still try. So it's fairly simple. However, if you really want to appreciate translucency very clearly, then I would suggest that you actually section the teeth. So section the teeth, and what I do is I usually scan the tooth section. Now remember, the tooth section is fairly thin, and we recommend a section thickness of barely 250 microns. So that's 1/4 of a millimeter. So it's a very thin slice. So this ground section can be placed on a scanner, scan it, and you can use a variety of software programs to measure the length. So now let me just show you how translucency length can be measured. And I'm actually very excited to show this to you because in the last 4-5 months I've stumbled upon this software which today allows me to measure translucency in a very nice way. Previously I used to use a software called as Photoshop, but Photoshop is a software which you need to buy. So I wasn't very happy that I can buy, but I'm asking others also because I conduct training programs. So other people also end up getting pirated versions of Photoshop. So you see the irony there, that we are working in forensics, but I'm actually encouraging others to obtain pirated copies of a software. That's completely a contradiction to the work we do. So this software is freely available, and if you find it useful enough, you're most welcome to make a donation at their website. So what do we do with this software? So let me just show you the scanned image, rather, not a photo, scanned image of a tooth section. So this is a tooth section here. Now what I do is, using a variety of tools on this software, I'll just try to delineate the translucent zone like this. And what I've done is basically set the limits of the translucent zone. This is the apical limit, and this is the coronal limit of translucency. Once you set the limit, you can just zoom in. You can just confirm whether you've set the limits properly, and if you feel there's any mistake, you can always modify it slightly here and there. You can just take it up like this. Now you notice there's a little bit of peripheral translucency also here. That is not to be considered. So that may be the result of some periodontal pathology, so we must not consider that. So I'm only trying to look at the physiologic translucent zone. Next I'll try to measure this, but before I measure, the units should be in millimeters. So let me change the units to millimeters here, and here I'm able to measure it. So I take this measure tool here and measure the distance. Well, it's coming as 8.7 millimeters here. Alright, so what do we do next? Let's go back and let's give it a try once again. So this is the formula that I'll be using to assess the age using translucency. Now remember, the translucent zone was 8.7 millimeters. So the calculation is usually done on an Excel spreadsheet. I don't even use a calculator today. I just do all the calculations on a Excel spreadsheet. So let me just enter that value here. Let me just increase the size of this so that you can see it a little better there. Remember, that was tooth section number 5. So I'm just going to enter the value 8.7 millimeters. Just press enter, and you notice that I've got an age of 57.86. So the actual age of this person was 58 years. So you notice that this has given a remarkably accurate age estimate. But again, don't get your hopes too high, because we may not get such accurate age estimates all the time. By and large, you can expect to get such great age estimates with zero error rates. You can get it in maybe just about 20 to 30% of cases. But I think you can expect an error rate of within plus or minus 5 years, which is considered to be good, by the way, in adults. You can expect to get that degree of accuracy in about half of the cases, so maybe 50% of cases. You can get an error rate of within plus or minus 5. Another 30 to 40% of cases, you may get an error rate of within plus or minus 10 years, which is considered as acceptable. And in spite of your best efforts, in spite of you trying very hard, a small percentage of cases, 10, maybe 20% of cases, expect to get very large error rates which are beyond 15 years, plus or minus 15 years, which means the actual age of the person may be 55, but you may end up predicting the age as 39 or 40. So expect to get such large error rates in a small fraction of cases. The reason for that is because we as a human species are highly variable in the way we grow, the way we develop. So these formulas can only capture some of the variation, not all of the variation. Consequently, the error rates can be large in a small percentage of cases. So, in spite of all of this, all of these advantages to translucency, there still are some disadvantages also. And once again, the issue of extracted teeth remains, although it's a single parameter that you're using, the issue of extracted teeth still remains. And another issue is that you may get certain sections which look like this. So you see, if you wanted to measure the length of translucency, you can start right here close to the apex, but then where's the coronal limit? Do you end it here, or do you end it here, or do you end it here? So you see, this is another problem with translucency. The junction of translucent and non-translucent zone is sometimes ambiguous. So there the solution may be to actually measure translucent area. Now we can use the same software which I just showed you to actually measure translucent area, but it's a little more longer, a little more complex. So I'll perhaps stop as far as translucency is concerned and focus on certain other methods. And the next method which I'm going to cover, I'm sure is also something very familiar to oral pathologists, and that's the use of Cementum incremental lines. Now, Cementum incremental lines is a little similar to the growth rings of a tree. Every year, the tree adds one layer, and you can actually assess the age of a tree by counting the number of growth rings. So similarly, it is considered that Cementum incremental lines add one layer every year. So by counting the number of layers, that gives us the age of that particular tooth post eruption. So you must also add the eruption age. So number of incremental lines plus eruption age gives us the age of the person. Some have found it to be remarkably accurate. So many have considered this to be one of the standard methods of age estimation. But over the last 10 years or so, there have been a few who have expressed a lot of displeasure at this particular method. They've talked about the problems they've encountered counting the Cementum incremental lines. So there are a few German authors who have said that it is not very accurate, and I myself believe that this isn't something which is very easy to undertake. We've done a couple of studies in Dharwad, and both times we've actually run into trouble. So what I will suggest is, if you're interested, try it out for yourself and see whether it works for you. The next method, I think, is a very easy to undertake method. It uses dental attrition. It was proposed by a couple of Chinese researchers, Li and Ji. Now, it's actually more than 20 years old, this method, and I feel it's a wonderful method, and I'm surprised that not many people around the world actually use this. What Li and Ji suggested was, in contrast to what Gustafson and Johanson had said, that use single rooted teeth, and on that single rooted tooth cusp, you just get one cusp and therefore one grade for attrition. So therefore Li and Ji have said, instead of using single rooted teeth or single cusped teeth, use the molars, which have multiple cusps. Therefore you get different cusps, and even if one cusp is worn out too much, you can always get it kind of averaged by the other cusps which may not have worn off too much. So that's the advantage of taking the average. Even if one cusp has attrited too much, and that may be a result of pathology, you can always, the other cusps, if they are slightly less attrited, kind of averages out the extreme value. Another thing that I like about Li and Ji's method is that they've given these very detailed diagrams as to how to grade, and they've given these detailed staging description for the various stages. 0 means no attrition, and you see 4 is where dentin has exposed, and 8 is where pulpal exposure is seen. They talk about secondary dentine exposure, which means that they're looking at pulpal exposure there. So I've tried this, I've used this method in a variety of cases, and I'll just show you its example in its usage in one particular case. And here, let's look at the first molar here, 4-6. Look at the two lingual cusps, and look at the two buccal cusps. I'm not considering the distal cusp because it's very small, very tiny, so you can disregard a cusp which you think is not suitable. So instead of 5 cusps, I'm using only 4 cusps here. So look at both the photo here and the cast. Compare it to the previous chart that you saw. And in my opinion, the mesiolingual and distolingual cusps were more or less 0. So I have staged it as 0. Now you may consider it to be 1. And I felt that the buccal cusps were stage 3. I thought that there was no dentinal exposure. The attrition was still within the enamel. So as a result, I've graded them as 0, 0, and 3 and 3. Now remember, we are taking the average. So add these up and divide it by the number of cusps. So the denominator is actually 4, not 5. So we get an average of 1.5. Now this is substituted in a formula. Now Li and Ji have given formulas, but of course they are Chinese-based formulas. Fortunately for me, we had a few oral radiologists from AB Shetty Dental College in Mangalore who 15 years ago actually studied this method, and they have developed certain formulas for Indians. Names of the authors are Mohammad Ajmal, Gopakumar, and Bharat Modi. So they have actually given this formula, so I've substituted the average here, and what I get is around 30 years of age. And as it turns out, in this particular case, the actual age of the person is also the same. So remarkably accurate, and that's surprising because accretion is not considered to be a very accurate method, but this formula, the average expected error rate is barely 3 or 4 years. So it appears to be a very accurate method, and I'll encourage you all to try this out and test yourself whether the claimed accuracy is indeed true or not. Lastly, we missed out on a radiographic method. So I can't complete my lecture without talking about a radiographic method, and that actually is something called as the pulp to tooth area ratio method. This method is also given by the same Italian researchers who developed the open apex method, and what they originally suggested was to use the canines. Their first study was on the upper canines, although we did a study on the lower canine, and that's the photo, that's the image that I'm showing you here. So the Italian researchers suggested actually measuring the area of the pulp right here and area of the tooth. So measure this, and then they suggest calculating the ratios so that we compensate for any magnification or angulation errors. Remember, the ratios will always remain the same. Whether you measured something on a tiny little photo, it's something like measuring my interpupillary distance to my interauricular distance. So whether you measure right here on my face using a caliper, or whether I give a photo of mine to you and you measure it there, that ratio will remain the same. So it's not really affected by any magnification or angulation issues. So what we expect here is that the pulp area goes on shrinking as we grow older. Why? Because secondary dentin deposition is resulting in more and more radio opacity, less and less radiolucency. On the other hand, we expect the tooth area to more or less remain the same. Probably because even if there is attrition, there may be a corresponding increase in the cementum apposition at the apex. So calculate the ratio, and originally software such as AutoCAD was suggested, but again today I use the GIMP software itself to use this method, and this is the formula that we have developed here in Dharwad. And let me again quickly show you how this method can be used. So I'm once again going to use the same software. So I've got a IOPA of tooth number 43 here. So what I'm going to do is use some of the tools available here, and just select the outline of the tooth like this. I'm trying to do this a little fast, so I may not get it perfectly, but I assure you that the age estimation outcome I think will be fairly good. So we are just selecting the entire outline. It's a little bit like tracing, using a pen or pencil. So just trace the outline. You just need a little bit of patience and practice to use a touchpad or mouse on a computer. So we've got the outline here of the canine, and what I'm going to do is there's something called as a histogram here. So I'm just going to use that histogram here. There. Here there's something called as pixels. I'll note down the pixels. That shows as 3424. So let me know. So remember, it was tooth number 43. What was the number again? 400?
24.
424. Okay, there. That's the tooth area. Now let me just check on the pulp area also. So I've used the same tool. It's called as the free select tool. Remember, you can also use Photoshop for this. You have something called as the magnetic lasso tool in Photoshop. That's what we use in Photoshop. So just create the outline of the pulp chamber and the root canal. It may be a little difficult here in the apical region, but again, just a little bit of practice and patience, you should be able to get it fairly right. So once again, let me note down the pixel value here. It says 49,056. So let me go back to that Excel sheet. And once I've got the tooth and pulp area, you see I've got the ratio also here. This is 0.14. Do you notice it says C6 by B6? So this is C6 here, that's the pulp area. B6 here, which is the tooth area. So I've got the pulp to tooth area ratio. And I've got an age estimate of 36 years. And this is based on an Indian formula, which I just showed you, which we had developed. So I'm not going to talk about these two formulas because I'm not going to be using them. So the actual age of this person was 34 years. It's from a real life case which we got about 4 years ago. So we used a couple of formulas, and the formula which we ourselves had developed proved to be quite useful in this case. So this is how we are able to assess age using pulp to tooth area ratio. And this, the advantage is that since it's a radiographic method, since it's a non-invasive method, we are able to predict age both in living subjects as well as dead individuals. So the major application of age estimation in adults, number one of course is in post-mortem reconstructive identification, but sometimes you may also get a situation wherein a living person comes to you and that person may not have any birth record. They may have been working in the government setup and suddenly they realize that they're more than 60 years. So we need to claim pension benefits. So we may have to predict whether that person is less than or more than 60 years of age. So these are some of the applications as far as age estimation in adults are concerned. Now, all of the good work that you do as part of your age estimation analysis is useless if you don't ultimately put that in a well-worded, well-written report. A report is extremely important. It's a legal document, so you must write it in a manner which the average person can understand and relate to quite easily. I say average person because the people who read your report are not going to be dentists. So if you use dental terminology, they may not be able to understand what you have written. So write it in a manner where a lay person can also understand. Consider it like your examination. You may be an excellent student throughout your fourth year or throughout your third year, but if you do not write well in your exam, if you don't perform well in your viva, there is no proof that you were a good student. So for you to get those high marks, it's essential that you perform well in the exam. So for anyone to think that you have done a good job in that particular forensic case, it's essential that you write a report which includes all of this information. The tone has to be professional, formal, good language must be used. So make sure all these elements are part of the report. I end up spending much more time writing a report than the actual analysis. I mean, you just saw how much time I needed to calculate the pulp to tooth area ratio or, measure the translucency length. So it really doesn't take much time, but it's the report that requires your additional attention and care. So with that, I'm happy to conclude this lecture.